video is recorded as part of the assessment. As you can see here, this is the project that I have did for this assessment. First of all, I will go through the components in this robot. There is a MyRio, and there are two breadboards connected to the MSP port A and B, and there are two motors, continuous rotation 360 degree servo motor, one connected to the left side of the robot and another one connected to the right side of the robot. Besides that, there is one line detecting sensor that will allow to detect the white and black surfaces. Rio is powered by a portable power bank from Xiaomi, and there is a USB boost converter that will convert the 5 volt coming out of the MyRio to 12 volts for this the MyRio is connected to my laptop through a modem, as you can see here, and I can control my MyRio wirelessly. Now I will explain the very first program that I have developed for this assessment. This demonstration will allow me to control the MyRio using a virtual joystick that can be controlled by my mouse pointer. So now I will directly dive into demonstration. I'm running my program. It's getting uploaded to the MyRio through Wi-Fi. It's uploaded now. Now I have two different ways to control my robot. One is through joystick method, which is shown here, and another one is steering method. To use the steering method, I will switch over to the steering method. These two steerings will control the power going to the left motor and the right motor. By default, 1.5 is the value that have to be given to stop and brake the motors, whereas 1 to let the robot go in clockwise direction, and 2 to let the wheels rotate in counterclockwise direction. Now say for example, if I want to move my robot front, I'll just steer it a little bit and steer this a little bit. So as you can see in this video, the robot is turning front with a little bit of steering towards right, which can be controlled by the value given to both the. So to come back, again the same, just reverse the values. So now let's take a look at how am I going to make use of this concept to control my robot using joystick. As you can see here, I have created a virtual joystick. The purpose of this virtual joystick is to track the movement of this mouse pointer within this region. As you can see, the X and Y values, it will track the coordinates of X and Y position of the mouse within this box, and based on this X and Y value, I will control the robot accordingly. So when I pull it towards this means the robot will go front, the robot stops, robot comes back, turn, rotate left, rotate right, turn left, turn right, and things like that. So now I will show you the live demonstration on how this works. The purpose of this blue box is to tell the exact direction on which the robot is heading. When I pull it on front, you can see that the blue box is moving towards the front, which means the robot will go facing forward. Now the robot is going facing backwards. Now the robot is going in front facing towards his right. Now the robot is going in front facing towards his left. With this, the second part of my assessment ends. This video demonstrates a basic version of line follower program. This program simply turns the robot left and right. When it is on the black line, it will turn the robot to the right. and if it is on the white surface, the robot will turn to its left. This way, the robot will keep following one of the outside corner of this black line. The line follower program, which does not have PID control inside. As you can see, the motion is very discrete and braking. This video demonstrates an improvised version of the basic line follower program. In this program, the P controller of the PID was implemented. The purpose of this controller is to let the robot follow the line more precisely and in a much faster way. When the robot is on the line, it will calculate the intensity of the black line, and based on the intensity, it will control the speed. In this video, Mario works as a sumo bot. The basic nature of the sumo bot is to push the opponent outside the ring, the black ring, but at the same time the robot needs to make sure that it stays within the ring. So the robot is searching for the opponent. The moment the opponent enters the ring, like this, it will attack him and push him outside the arena. And once it reaches a corner, it will try to reverse back to make sure that it doesn't exit the ring. So to achieve this, I had used two infrared sensors, one on the left of the robot and one on the right front of the robot. And the robot will steer accordingly based on the position of the obstacle. And to make sure the robot doesn't enter the invalid zone, I had used a line detector to take the edge of the ring.